This is Fernando Medina, and you're listening to the Bladeology podcast.
Okay, so we're going to jump into it like we do every week. Welcome to another episode of the Bladeology podcast. We are on for episode 29 this week in the year 2020, if you can believe it. We are here with a guest tonight, and we are here with a modified host lineup. This is the vocal representation of Jeremiah Burbank from PVK Vegas.
Nick Chuprin of NCC Knives.
And who do we have on as a guest this week?
Laren Thomas.
Laren, welcome to the Bladeology podcast. I have been intrigued by your Instagram, the Knife Steel Nerds, for a while now, and we finally were able to set up this talk. I'm pretty pumped, actually. So let's go over it. So why are we here? Why are we talking? What do you do, and how did you get to start doing it?
I am a metallurgist. So I work in steel professionally. So I develop automotive sheet steels. The reason why I got into steel in the first place was from knives, which is why I have the website, Instagram, all about knife steel. So the reason why I got interested in knife steel is because of my father. So his name is Devin Thomas. He makes Damascus steel. He started making Damascus in the early 90s, late 80s, and he was making knives before then. So it was just around my whole life. That was his full-time job for as far back as I can remember. And so, every day he went to work and made Damascus, and he would sell it to different knife makers.
The one and the only famous one. Yeah, no kidding.
Yeah, so he always told us that he was famous. So at school, we would brag about how we had a famous father. And the kids at school would ask us who he was, and we'd say Devin Thomas. And they never knew who we were talking about. So.
They're hanging out with the wrong kids, man. Gotta hang out with the knife kids.
That's like an inner joke we have as knife makers and people in the community. It's like, oh, I'm famous in this small community you've never heard of.
Yeah, so knives were always around. My dad would make a knife here or there, as that was his original passion, was knives. Damascus was kind of the business that grew out of that. And so, I had some interest in knives. I wouldn't say a ton of interest. We'd get in like the A.G. Russell catalog or something in the mail, and I would check it out and like, oh, this knife looks good. And my dad would say, that knife's garbage. Or you need a knife in 154 cm, not this 420, or, something like that. But then as a teenager, he started taking me to knife shows. I guess before then, he took me to a hammer-in or two, which was kind of fun. We went to Montana for those hammer-ins up there and had a good time there. And at the knife shows, there were always knife makers that would brag about how their knives were the best. They cut longer or cut better, or they had secret steels or secret heat treatments. And that was always really interesting to me. And that is kind of what led to my interest in metallurgy. So, I started reading everything I could in my late teens. There was a book on metallurgy for knife makers by John Verhoeven that came out around when I was graduating from high school. But he had sent a couple draft chapters to my dad. They were familiar with each other. And so I was able to read that and learn metallurgy. And I went to school for a long time and got my metallurgy degree. And yeah, so. But, I like my job working on automotive sheet steel. It's a good job. It's an exciting area to develop steel in. But, I wanted to do some stuff with knife steel. That was my original interest and passion. And so I decided to start the website and start doing experiments on steel. So, and it's been a good time.
Yeah. I'd like to know, how'd you end up acquiring a Catra machine?
I am consulting for a major knife company. I'm not sure if I'm allowed to say which one. And they recently bought a new Catra edge retention tester. And so when we were talking about consulting and how I would be paid, I asked them about their old catcher tester, and they said that it was kind of old and broken down. And I said, well, how about instead of paying me money, that you ship me a catcher machine? So they did. It was very broken by the time it got to me, mostly from shipping. The problems that they were having with it, I have not experienced at all. The only problems I've had were new ones from shipping. But I got it fixed. It took me a month and a half, 2 months. So when my wife found out how much money I gave up to get the machine, she was not that happy. And I've only spent more money since then. So,
Well, whenever Jeremiah told me you were going to be one of the guests, I checked your Instagram out. I wasn't too familiar with your Instagram. I saw the machine. I was like, wait, how serious is this guy about knife steel? I'm like, those aren't cheap machines. Also, now that you said you work for a company, I'm pretty sure I know what company based on the machine you had.
Well, some companies are more vocal than others about their use of the catcher machine. So the most vocal is probably Spyderco, maybe number 2, Benchmade. There's a couple other companies that have reported various
for the most
studies.
Part, it's usually just kitchen knife manufacturers that actually use a catcher machine. But it was that when I saw that, I was like, oh, he's actually pretty serious. It makes a little bit more sense that you got it in the trade for work, because I was like, did he purchase one of those machines for his passion of knife steels, or what was going on? Because I'm like, those are really expensive.
Yeah, I never could have gotten one. They're in the tens of thousands of dollars. I could not have justified that, no matter how much I like steel. So.
Yeah, I told Jeremy, I'm like, yeah, is this a hobby for him, or he's really serious as a career? Because I'm like, that's an investment. Well, okay, it makes a lot more sense. Pretty cool. I've seen some of those in action before. Pretty neat.
Yeah, I like it a lot. So it's been fun testing it. So I'll have an article on my website in the next few days summarizing the tests that we've done so far. Because I heat treated 50 some odd blanks out of different steels, a few with a range of heat treatments. And I had Sean Houston, he's a knife maker in Oregon, grind the bevels on them. I am a very bad knife maker, and I don't have nearly enough time to grind 50-something knives. So he ground them for me, and I've been testing them all, and I got to retest them. So that means we had to get the same sharpening setup and the same stones so that I could resharpen them and test each one 3 times to get a good average. And so that'll be a really big article. Apparently, the only thing people care about is edge retention. It doesn't matter what else I talk about. They just want to know which steel cuts longer. So I will finally give them what they want.
I mean, there's a 2-part interest there. First thing, can we go over what exactly that machine does, just for listeners who aren't aware of exactly what that does?
Yeah, sure. So the machine is very complicated to do something that is pretty simple. It cuts paper, basically. It could accommodate other media, but it's designed for these stacks of 10 millimeter wide paper. The paper has about 5% sand in it. And what the sand does is just wears the edge faster. And so the machine puts the stack of paper on top of the knife under a fixed load, and then it moves the knife back and forth. And so as it cuts through the paper, the head of the machine travels downward. And so the machine measures how much it's traveling downward with each slice that it performs. And so with each slice, it's going to cut a little bit less each time because the edge is wearing down. And so you get a nice curve of paper cut per slice. And so, and then it tallies up how much total paper it cut through over the full course of the run. And so you can compare different steels or different edges that way. As you can't compare 2 different knives and then say it's a test of steel, for example, because the edge geometries are different. They could have even been sharpened differently if you're comparing them straight from the manufacturer. So you're comparing a whole knife. So if you want to compare just steel, you got to make sure every other variable is the same.
Wow. Okay. No, that's highly logical. So the machine basically slices sheets of paper, And then, so if I'm looking at like a regular drop point blade, I assume. I mean, are these ground a specific way, or how does that work?
Well, it can accommodate different shapes. The best shape to use is just a straight edge, because if there's any kind of curve to the edge, that will affect how it's cutting. You can imagine if it's cutting uphill versus cutting downhill, like cutting into the curve of a blade, then that would affect how it's slicing. So for these tests, they're all straight edges. They're just simple rectangular, like shaped blanks with an edge on them. So that's what we're testing right now.
So just basically almost like a Warncliffe, like you're talking about, like literally straight.
Yeah, they're 1.5 inches wide. They're 4 inches long, and then they've got about like a 2.5-inch edge ground on it.
Yeah, I saw the photo there. You had more like of a full flat kitchen knife style grind on there.
Yeah, almost like you took a cleaver and then just like chopped off most of it. Oh.
So we did really jump ahead here because I really wanted to talk about the Katra. Before I forget, to later, there's a specific test that if you ever get to, I'd like you to do. It's a test that's been argued a lot about back in the day. Have you ever thought about comparing forged versus not forged steel?
Yeah. So that has been, well, we've even done it some. So I've done a lot of toughness testing over the past couple years. The Katra is more recent. So we've compared forged 52100 versus stock removal 52100 for toughness. Now the toughness tests, I gotta describe a whole nother test now. So the toughness test, we do a Sharpie impact test, and they are also rectangles, but there's no edge put on them. And there's a really heavy weight, like a hammer, and it's on an arm, and you swing the arm all the way up to a high angle, and it's held like with a stop. You put the sample down at the bottom of the machine, then you release the hammer, and it falls through the steel rectangle and breaks it in half. Now, if there were nothing there, like no steel specimen, it would travel all the way back up on the other side at the same angle approximately, minus friction. But when it breaks through a piece of steel, there's some energy loss, so it doesn't travel all the way up. And so the machine, measures how far it traveled up, and then that equates to the energy that passed through the steel. And so that can be translated to some extent to chipping resistance in a knife. So we've done toughness experiments where we had forged 52100 and stock removal 52100. And I mean, they were largely the same. The forged was a little bit better, but it's not really because it was forged. It's just, the microstructure was a little bit different. The annealing treatment was different. So, the end structure of the steel ends up a little bit different. And so in this case, it was, 10% better or something. In case of edge retention, it's unlikely to make a difference, but if a knife maker wants to send me a couple blanks, he wants to forge one and not forge the other, then we can talk. You can email me.
Are you actually doing, after that's done, are you doing a snap test to check on the grain structure of the steel? Old story of a knife maker. I used to work alongside NJ Steel Baron, so I met a lot of forgers over that time. Old story about a forger who specifically forged D2. And I forget what the scale is used to actually check the grain of the steel and how fine it is. But I remember he specifically used to do D2, and Niagara did a bunch of tests, or Crucible did a bunch of tests on his D2, and he kept telling them that he could get his D2 finer, as fine as a powder steel. And you're familiar with D2; it's not a very fine steel. He forged it and he treated it in such a way that he would get it to as fine as a powder steel. He'd submit it to Crucible or Niagara, and they'd test it, and they'd be astonished at the results, and they would try processes to mimic, like microforging the steel as it's rolled out and stuff like that to mimic his results. They just couldn't get it, and that was the main reason why I asked if you did tests on forged versus not forged. If you've noticed, I don't know if you're doing snap tests on the steel to check the grain structures or anything like that. That was the main reason, because 52100 is pretty fine in itself, compared to something like D2 or some of the 10 series.
Okay, so you've opened up a lot of things. One is a great story about the metallurgist that couldn't couldn't match the knife maker and his astounding forging skills. I don't know if that's true or not. It's a good story. The other is where you're talking about refining the grain, but also D2, its grain size is not that coarse. It's the carbide structure, which is. And so grains and carbides are two different things in steel. So grains are a little bit harder to explain. So I'll start with carbides. So with carbides, they are hard particles in the steel. Carbide, it's a form of carbon combined with either iron or other elements. So in D2, for example, it's got a bunch of chromium, so it forms a lot of chromium carbides in it. And those can be difficult to control their size, especially when there's a lot of it. And D2 has a lot of chromium carbide, so they tend to be large. And that makes the toughness of the steel worse because the larger carbides are easier to fracture. And so the steel will actually initiate a crack at those big carbides and then grow through the rest of the knife, for example. So those are carbides. And grains are individual crystals in a steel. So in steel, there are all these repeating arrays of atoms that are all in like a nice grid-like structure, sort of. But they're not in that perfect array all throughout the steel. They will change direction, and there'll be multiple different crystals, all with different orientations of that grid pattern that are all combined together. And so those all form grains, and you can see those if you use special acid etchants, like you polish some steel and you etch it in acid, it'll reveal those boundaries. And you can even pull them out like little three-dimensional little crystals if you etch them correctly. Now, you also mentioned fracture grain. So if you break a brittle piece of steel, the fracture surface will sort of represent how fine the grains are. So you're not seeing the actual grains, but there's a very good correlation between the fracture appearance and the grain size. And so whenever I break a specimen in a toughness test, you can see the fracture surface because, it's broken. It's just like any test where you broke a piece of steel.
Yeah, I used to, NJ Steel Bar, every time they got a new steel, we would pretty much do that to see the structure. Just quick, easy, like you mentioned, it's an easier way to do it, and you get a rough idea of what's going on when you just snap a hardened link.
Mm-hmm. And so refining carbide structures, a lot of forging bladesmiths don't forge those higher alloy steels like D2. They find them difficult to work with or crack more easily, or they want something that's easier to anneal in their forge, which is difficult to do with an air hardening steel like D2. It is possible to some extent to refine carbide structures through forging. That would be very difficult to do with D2. And that is because the carbides are stable up to the melting temperature of the steel. So you can't just forge it really hot and get rid of the carbides and make them reform smaller. And actually heating it up to high temperature also causes the carbides themselves to coarsen. They actually get bigger. So you have to forge in the correct temperature range, and with enough reduction, you can shrink the carbide somewhat. Making them as small as a powder metallurgy steel sounds unlikely, but maybe Crucible would back up the story. I don't know.
Yeah, I don't remember which one. I don't remember that forger's name either. It's been a while since I've gone over that story with Aldo. It's definitely been about 3 or 4 years. Next time I see Aldo, I'm gonna ask him though. I'm curious now too. Sorry, I forgot about. But yeah, I remember talking with. I guess it was Niagara because I remember talking with Jeff about it, which is one of the reps at Niagara.
Mm-hmm. Yeah, Niagara Specialty Metals. They roll out all of the Crucible steels. They're one of the only companies that can roll out steel, these kind of knife steels down to the right thickness that we need. So Niagara is a cool company. So they also sell steel directly. But you guys don't have a sponsorship with a steel distributor, do you?
That's right. Not yet.
No.
Working on it though. All right.
I just buy the stuff. Fortunately, they don't pay me.
I just sell the stuff, I guess. I don't know. All right. So yeah, let's dive back a little bit. I've built up a few questions here, but so how did you? I mean, obviously, okay. So Devin is your dad, and steel's been a part of your life forever. But there are some interesting tidbits that I'd like to go over. So how did you? What was the point in time where you were like, okay, this is it. Like I'm gonna take steel seriously, and I'm gonna become like a metallurgist. I'm interested in that process. How did we get there?
Yeah, that's a good question because I never thought that engineering or science was really a possible career path for me. I did fine in school, but not amazing. And I would have thought of engineering or science as something for really smart people. And I never did particularly well in math in high school. So I went to a very small high school. So we moved to a very small town in Nevada when I was 8 years old. And so I had one math teacher from eighth grade through my senior year. And I think he was a fine math teacher, but he just didn't connect with me. And I had a hard time really figuring it out. And so I went to junior college because I wasn't a spectacular student. Maybe I could have gone to a better school, but I really didn't know what I was doing. So I went to junior college and I took a math class from Mr. Bowler, who was a lawyer who taught math on the side. And he was a really expressive, funny teacher. And so he just everything he said made sense to me. So he would teach a class on math and just everything connected. I could get to the exams and I just knew everything to do. I was getting straight A's on every exam. And that really built my confidence. And so, during that year, I spent a lot of time thinking about what it was I wanted to do as my career. And I said, hey, like I'm smart enough to do this. Like I can do math. And if I can do math, then, I can do whatever I want. And so I started to think about material science or engineering seriously as a career. So I transferred to University of Nevada in Reno. And I started in material science and engineering, and I soon discovered I wasn't as smart as my Mr. Bowler math class had told me I was, because the students were very smart in the engineering program. All those kids had gone to big high schools with big AP programs. They'd taken AP chemistry and physics, and I was definitely a step behind those kids. And my new calculus math teacher at University of Nevada was not nearly as expressive and entertaining and easy to understand. So I was thrown in the deep end again. Engineering is a tough field to go into. So normally it's smart people that go into those fields, not me. But I was able to bumble my way through as an undergrad. And I was getting to my junior year or so, and then like, oh man, graduation is not that far away. What am I going to do? And I thought about it, and what I always wanted to do was develop new steels. And to do that, you typically need a higher level degree, at least a master's, but a lot of times a PhD. So I started looking at grad schools. I emailed John Verhoeven, the professor who wrote that book on metallurgy for bladesmiths. I emailed a couple other professors I knew. One, George Krauss, he edited the 5th edition of Tool Steels, which was a fun book. So I emailed those guys, and they told me I should go to Colorado School of Mines, which has a big steel research program. So I contacted the head of that steel research center, and I said, hey, I love steel. I started talking to him about all my favorite things, vanadium additions and grain size or whatever. And he said, I think you'd be great for your program. You should start studying for the GRE and make sure you get a good score. And I was like, what is the GRE? I knew nothing. I still know nothing. I took the ACT late. I didn't know what the GRE was going into grad school. So I studied a bunch for the GRE. My GPA wasn't that bad. I got a couple of C's at University of Nevada, but my overall GPA was pretty good. And so I was like, hey, I can go to grad school. And, I can go to this really nice school and do steel research. It'll be awesome. So I studied hard for that GRE. I got a good score. I got into the school. Colorado School of Mines, the Steel Research Center was amazing. So the professors all know everything about steel. there are some schools people go to and do steel research, but the professors, they're good metallurgists, but they don't know steel specifics, and they can get away with little errors or bad logic on steel. But that was not possible in the Steel Research Center at Colorado School of Mines, because they all know way more than I do to this day. So it was a really good program. We worked directly with steel companies all the time. We would present our research to them. And so that's when I got more interested in automotive steel, because it's a really big area of research. Tool steel is a much more boring industry these days. There's not as much going on. Not nothing, but not as much as steel for cars. So yeah, I went there for 4 or 5 years to get my PhD in metallurgical engineering. And that was very challenging. So I said University of Nevada was hard, and Colorado School of Mines was more difficult, because they weren't students getting bachelor's degrees. They were now students getting PhDs. So they were even smarter than those smart kids from the suburbs at University of Nevada. So yeah, I had a really good time there. The research was really good. The classes were good. And so it was challenging and fun. And that set me up for my career now. And, that's a big reason I had the confidence to start writing for Knife Steel Nerds and to do my own experiments, because I learned how to do all of that in grad school. So I wasn't nervous. I had done a lot of the things, doing microscopy or doing toughness tests. So this was not something that scared me.
So this is just kind of an extension of what you had been doing before, almost.
Yeah. Yeah. In a lot of ways. I mean, as an undergrad, you do some lab classes and things. And I kept reading about knife steel on the side all I could. Unfortunately, in material science school, they don't start every class by telling you about steel. They want to talk about broader materials categories, of which steel is only a small part. So I try to pester professors into letting me do little projects. I remember I was trying to do different heat treatments to refine grain size on a stainless steel, and I had to develop an etchant. And the professor funded me to do this little project, which was mostly a failure, but I did manage to look at the grain size. So there are always professors that are willing to work with you. If you show some interest, the professors are just as excited as you, because they're just used to students looking at them with glazed eyes during every class. So, and it was the same getting into Colorado School of Mines. I called and told them how excited I was. I think I could have had a worse GPA and got a worse score on that GRE, and I still would have got in, because, people like enthusiasm.
That they do. That's absolutely true in any subject, and I would imagine in a specificity like you're speaking of, that's really that counts for a lot. I can only imagine how psyched they were to have somebody truly be on their level with steel.
Yeah, and I have no idea why anyone else gets into material science or metallurgy. I ask people, and they're usually like, oh, I had a teacher here, or, I just randomly chose an engineering, area or something. There's definitely other people that are interested in specific things. But yeah, so for me, I had this very specific path and interest, and I when other people pick their career path, I have no idea how to help them.
So then into the automotive industry, I don't know how much you can divulge of that, but I mean, do you work for like do you work for like GM or Honda, or do you just sort of work for like a blanket organization that represents like steel in manufacturing for cars?
Yeah, I do not work for a car company. I work for a steel company. I work for U.S. Steel Research, which is the research division of U.S. Steel, United States Steel. So the research is in the Pittsburgh area, and so we develop new steels that will go into cars. So they're always raising safety requirements and gas mileage requirements for cars. Of course, just in general for consumers, they want to improve that every year, and to do that, they have to move up to better materials. And cars are still largely made out of steel. There's some other materials that go into them. Aluminum is a big one, and plastics and things that don't need any structural integrity. Maybe you look at a car and think they haven't changed that much, but the steels have gradually, steadily changed, especially over the last 20, 30 years. So every year, the car companies want stronger steels at the same level of ductility. So their strength and ductility. So ductility is like how far you can stretch something before it breaks. Strength is how much force you need to break it. So it's almost any time you increase the strength of something, the ductility goes down. So just like in a knife, if you raise the hardness, usually the toughness goes down. It's a similar concept. So the car companies, they want the steel to get stronger, but to also be just as ductile. Now, at the same time, to make steel that is both stronger and more ductile together, we need to change the composition. We need to add more carbon or more other alloying elements. But the car companies also want us to keep the composition the same, or basically the same, because the more alloy and carbon you add, the worse the weldability is. So we have a lot of demands that we're trying to meet at the same time. It's got to be stronger. It's got to be more ductile. It still has to be weldable. We have to be able to make it in our manufacturing facilities. And then there's other properties too. There's not just the normal strength and ductility. There's other specific types of tests, like there's hydrogen-induced delayed cracking, for example. So there's just lots of these random properties, and you're trying to get all of them to work all at the same time. And it's pretty difficult sometimes, but it's fun. So it's a lot different than tool steel, knife steels. They're a completely different set of materials. They're both iron-based. They're both called steel. But the reason why I can work on car steel and then come home and do my hobby on knife steel is because they feel very different from each other.
Okay, so for the automotive side, we're talking about steel and all. Like what the hood's made out of, what the frame's made out of. All the steels, or is there any specific? You guys are just trying to solve this problem constantly for whatever is necessary for the company?
Yeah, so a lot of the steels I design are for what's called the body in white. Now, even though I make car steel, I am not an expert on cars, so hopefully I don't misspeak on anything. They tell me like, oh, this will be for a B pillar or an A pillar, but I usually have to look up what that is. But so the body in white is kind of the structure underneath the car. So the hood and the outer body is usually a relatively low carbon steel. They might make it a little bit high strength, like to provide some dent resistance, but a lot of what I'm designing is for the structure of the car.
Okay, no, that makes sense. Okay, yeah. I never even thought about the pillars and everything being completely different steel, but I suppose there's different stress on every part of the car and turns and everything. So that makes total sense, actually.
Yeah, the more advanced they've gotten, the more they, way back in the day, it was all simple, mild steel, and they would adjust the structure to compensate for the properties of that material. Now, as they're trying to make the steel thinner and thinner to lightweight the car, then, they end up making each component of the vehicle out of a different specific strength level of steel or different type of steel. So it gets more and more advanced the more development goes on.
Yeah, think about it like this. You want the frame to be strong, but you don't want it to be tough, so that way it doesn't shatter. But then, think about a bumper and a hood, it has a bounce back factor, almost like a spring temper. It's not probably not spring tempered, but the steel has, I would assume, bounce back properties, maybe referred to as ductile. I'm not exactly sure. But
the car has designed in crumple zones. So, you have to have steel with very high toughness to be able to crumple and absorb the energy of a crash. So this is part of why people complain about cars being so easy to break these days, is because when you run into something, your car is designed to absorb it rather than you. So you can see videos. There's a good one where they crash a Chevy Bel Air into some kind of 2009 Chevy. And the old Bel Air, which is just made of like really old thick steel, you think would do amazing, but the test dummy just gets destroyed in the car.
Yeah, and the old Bel Air was pink.
Yeah, so the new car, the test dummy's fine. The car absorbs the energy, the airbags and everything do great. The old Bel Air, just the engine basically ends up in the lap of the test dummy. So the engineers, I think, know what they're doing. I know about the steel part. I assume the automotive engineers know that part.
What decade are we speaking of that you started working for the automotive industry? Are we driving cars now that you had some form of input on?
No, I started working professionally in 2015. So I don't know if there are any vehicles with. Well, there are vehicles with steel that I have worked on, so not ones that I developed from scratch, probably. But steels that weren't working as intended, like we have high losses on a specific product, and I'm asked to fix it so that 90 or 99% of the steel is meeting the specification. It can be shipped to the customer rather than being scrapped or rerun. I'm given a project to fix that so that we're not throwing away so much steel. So there's probably cars out there with steel that I had a hand in or fixed but I don't think there's any cars yet with steels that I designed from the ground up.
No, the important question is, if you've designed from the ground up, do you get to name it?
No, usually the steels have very boring names. Well, I guess our marketing usually comes up with names, but then the car companies, they don't care about your marketing name. They'll have some generic name for it, 780 TBC DC or whatever they want to call it. And you'll say, oh, we have our 780 trip product. Aren't you excited about that? And they're like, hold on, let me look at my sheet. You mean 780 TBDC? You're like, yes. Oh.
I only said that as a joke because I like the joke about that I named Nitro V.
Yeah.
So that's the main reason I use it.
That is Nick's go-to steel naming joke.
Mm-hmm.
Okay, so automotive, and then we transfer into. So you're doing this automotive stuff, and you're bored. You want to get back into knives. Somehow you're just like, I want this hobby to be more real.
No, not bored, boss. If you're listening, I'm having a great time at work. I enjoy my job very much, but I also love knife steel, and I want to work on knife steel.
Right. So how does that transition work? Because you said when we started that you're working with a sort of confidential knife company now. Did you just how does that connection work? Is there any automotive to knife, or was knife always an underlying thing the whole time during the automotive process?
Yeah, knife steel was always in the background. That's what I learned about from the beginning. Reading the book from John Verhoeven, for example, or reading that book on tool steels from George Krause. I was reading all of those books. I joined various knife forums around 2001 or so. And, I was discussing knife steel and knives from then on. While I was in grad school, that slowed down some. I wasn't participating as much. I don't know if my interests were shifting a little bit at the time. Also, I wanted to focus on grad school. I was very busy then. And then after I was done with grad school, I started getting back into it some more, chatting on the forums and talking about steel and heat treating and things. And I was like, well, I'm a metallurgist now. I can write about these things a little more legitimately. So I wrote up a post or two just on blade forums in the shop talk section, which is used by knife makers. And I wrote up a couple things. But on a forum, you discuss things and then it goes back to page 2 or page 3 and then it's gone. Like I wrote a little mini article for blade forums about cryogenic processing. And then it ended up on page 3 a few days later, which is fine. But then a knife maker came on and asked questions about cryo. And I'm like, you got to be kidding me. I just barely wrote about this. So I thought, well, if I make a website, then it'll be a little bit more long term. It'll have kind of a collection of different things that I write about. So if I write something about cryo, then it'll be there, for whoever wants to look for it. And so that's where I started. And originally, I was targeting mostly knife makers, and maybe I still do, writing about different parts of heat treating to knife makers. This is how this works. These are the variables that change the end properties. This is how you control your hardness or your toughness or your corrosion resistance. And that is what I primarily wrote. And I didn't really have the equipment to do experiments at home, but there's some equipment I'm able to use at work. So my dad did some studies with me where he forged out some steel and he treated it different ways, and we tested the toughness, for example. But then I started a Patreon and got some money through that. I was able to buy a heat treating furnace and some steel and a bandsaw and that kind of stuff. and start doing more experiments. So originally it was just writing articles, like this is how steel works. Then it was doing more experiments, and it grew a little more. And a lot of knife enthusiasts and buyers also read the site. So I'll write articles targeted at them a little more. It's a struggle because I'm trying to write about very technical things to a lay audience and mostly failing. So some people are like, oh, these articles, they're so great. I love them. I'm learning so much. And then I get the random person that says, I tried to read this. I didn't get any of it. And I was like, oh, man, because, all I want to do is for people to understand. But it's so hard to write things in a way that's both technical and covers all the bases and also is easy to understand. So I'm doing my best.
I mean, I can understand I'm able to keep up as best as I can. You're doing a great job explaining, but I can see why people might get a little overwhelmed by the technological aspect of the subject. But I mean, great call, just making a website. That's then you're always on page one. You're always there, easy to find.
Yeah, I think websites and blogs are kind of an outdated concept now, but I'm getting older, so
just got to evolve with the times.
Yeah.
Social media has been great at that.
Yeah, I'm also working on a book, so I'm going back in time slowly. I'll switch to clay tablets next.
Okay, yeah, definitely inscribing on slate is always good. I see it in the graveyards all the time. It seems to last for a while.
Mm-hmm. Yeah, the acid rain, it takes a while.
Mm-hmm. So working with so you're saying you're writing these articles, they're for different sects of the same community, but working with production companies. Can you talk a little bit about that?
Yeah, a lot of what I'm doing is independent. I'm not necessarily sponsored by a steel company or anything. I have gotten donations, both from my readers through Patreon, but also different steel suppliers will donate things to me. You can see that on Instagram. I'll say, I just got some of the new M398 steel from Alpha Knife Supply, for example, or I just got in some Rex 121 from Niagara. So I have gotten some good support from some of those companies. Only one or two of the studies I've done have really been commissioned by them. Some things are expensive to do, or a company's interested in it, and of course they hire me and say, be unbiased, just let us know what the result is. But I always say in the article, I got this steel donated from this company and this steel donated from this company. So if you think I have a bias, then let me know. I'll check my biases and see how I'm doing. And occasionally that comes back to bite me. I won't name names, but there is a steel supplier that kind of commissioned and designed a little bit their own steel, and they sent me some of it. And I tested it, and I said, it's not any different, really, than this other available steel. And they were not that happy with me. So,
yeah, I'd like to actually talk to you about. I'd like to talk to you about that later.
Okay. But I've
off the recording.
Mm-hmm.
But I've tried to expand what I'm doing with production companies a little bit. I've worked more and more with them, trying to do consulting projects on the side. I'm also in talks with a supplier on one knife steel project and a knife steel company on another, where I'm trying to get a steel, a couple different steels of my design produced, where I want to make new and exciting properties that aren't available in the knife steel industry right now. So those seem to be moving forwards kind of slowly sometimes. But I'm really excited about that. So designing knife steels was really one of my big dreams from the beginning. As a teen, talking to the crucible metallurgists about S30V or whatever the new exciting steel was at the time. I always wanted to make something new and cool with better properties than what was available before. So hopefully we'll be able to make announcements on that in the future.
Yeah, it takes a lot of money to roll out to do a custom roll.
So all the tests are totally non-biased. You're not sponsored by like Microtech or Spyderco or anybody. You're 100% steel 1000% of the time. So it's really who was ever manufacturing it is almost second to how the steel performs.
Yeah, I'm a fan of all the steel companies. There's some I like more than others. I've had good interactions with Crucible metallurgists in the past. They had a bankruptcy in 2009, so a lot of those research metallurgists are working at other companies now, or some of them are approaching retirement probably. I've always had a soft spot in my heart for Crucible. They came out with S30V around 2001, and that was really exciting to me at the time. But if a cool new steel comes out from Udahome or Bowler or Carpenter, then I want to know about it. So I'm excited about it all.
Yeah, I just wish Carpenter's supply chain was a bit better.
Yeah, everyone complains about that. Even the suppliers that have good relationships with Carpenter, they just don't seem to be on the ball with that. It's kind of disappointing.
Pretty familiar with that.
So Carpenter, get your act together.
Yeah, I'm sure they're listening. Mm-hmm. They're probably they're here.
Yeah, Mr. Carpenter, he's listening right now.
That's it. Okay, so then the steel tests. Okay, that's the next thing. So then you're here doing these tests. Like how much like time, money, how do you figure out what tests to do? Is it driven by like consumer interests or steel people interests? Like how do you figure out how to do these tests and what tests to do?
Yeah, that's a good question. A lot of it is driven by my interests, but there are other people that have input. So, I've done a lot of toughness testing the past couple years. And I announced on Blade forums, like, I'm doing toughness testing now. If you have the capability of heat treating or grinding specimens, then make them and I'll test them. And I've even been criticized by one or two people for doing that. Like, oh, if you were a real scientist, then you would just make them all yourself. But real science can be done by normal people. And, this is a community effort. So I can only do so much. And the more people want to contribute, the more we will all learn together. So, when someone says, I really want to see how tough this particular steel is, how tough is 3V, or can Z tough beat out the toughness of 3V or something, then, let's do it. And so, I test the toughness, and what they're interested in is what I test. Now, also on my Patreon, I occasionally do a poll like, I'm debating between working on this project next or this project, which one are you guys most interested in? And they'll do it. But, I also turn down things. People say, oh, there's this debate about if 204P can cut longer than 20 CV or whatever their debate is. And like, it's really not that interesting. They're probably going to be about the same. I've got limited amount of time. So if we get around to that in the future, then sure, we'll see how it does. But, I can't do everything. So things are filtered through me. If I think it's just not worth doing, then I probably won't do it.
I mean, I have to ask just because I sell knives constantly. It's what I do in my day job. And I'm just pulling my hair out over people asking me obnoxious questions about knife steel. Do you find that people just don't give up sometimes with their line of questioning, thinking that it's like the end all be all, and you're trying to be more technical about it?
Oh, of course. I mean, even when I investigate something, one of the boring questions, I say, okay, well, I have the resources to do this. I'll just do it. And I look into something and I see no difference, or, somebody says this steel way outcuts this other one, and I test them and it's the reverse. Then, normally they get in the comments and say, well, you did it wrong. You're supposed to heat treat it to 62 Rockwell and you only heat treat it to 61 Rockwell. So when you go and test it at 62 Rockwell, then come back and let us know how it goes. So I change some people's minds, and those that have their sacred cows, they'll just keep holding on to them.
Okay. Yeah, that's probably a good way of looking at it. I can't imagine. I have some idea, but I can't imagine someone in your profession doing what you do on social media. The trolls must be intense at points to where people just don't want to listen to like the scientific fact that you're providing them. That must just drive you insane, I'm sure.
Yeah, I'd say it's not too bad, but it definitely happens. Sometimes it comes in waves. Sometimes I'm amazed. Like when I was a teenager or a young adult, and, I got a chance to talk to a Crucible metallurgist or John Verhoeven, I just worshiped them like they knew everything and could say nothing that was wrong. And then sometimes people talk to me like I don't know what I'm talking about. Like they know everything, and if only I would listen to them, then I could learn something. And sure, sometimes people have some things to teach me, but I've been doing this for a while, and when they talk to me like I'm the one that doesn't understand, then it's a little bit infuriating sometimes.
Yeah, I can imagine, because certainly you obviously have a good idea of what you're doing here. Okay, so I have a basic question then. So you're doing these steel tests, and they're well done, and they're analytical, and there are zero biases. But my question is, so when a company, any knife company, buys the steels that you're testing, I mean, is there, you know what I'm saying? Is there like a translation between the tests you're doing and then like a finished product? Like if I go buy like a paramilitary 2 with whatever, I don't even keep up with that stuff, whatever steel is on there, you know what I'm saying? Is that test comparable to how they treat the steel? Like, are your tests based on the same treatment, or your tests based off of how the steel should be heat treated?
Yeah, there's a lot of ground to cover here, and I think I'm going to forget about 100 things. But there's the engineering of the final knife, and that knife, the design and engineering of it has 1,000 different components to it. There's the edge geometry that they're selecting. There's the shape of the blade that is hopefully designed for its intended application. The design of the tip. How heavy the tip is going to be. And so that all goes into it. The finish that they're going to use on the knife, and then the steel is just one part of that. So you pick a steel to some extent based on what the market wants, to some extent based on the performance that it'll provide for the given knife, and then of course you have to heat treat that steel. And there are differences in heat treating between industry and knife makers. So a lot of my content is geared at custom knife makers. I don't do heat treatment studies specifically for knife companies usually, because I just don't have the equipment. You're talking about very large vacuum furnaces usually, where a knife maker will have a small furnace, and they'll wrap the steel in foil and then plate quench it or air quench it, or with a low alloy steel they'll oil quench it. And so those are usually the level of studies I'm doing. But surprisingly, when a metallurgist at a steel company is developing a new steel and selling it to industry, they'll do small-time laboratory tests just like what I do, and then try to translate those to the production companies. So can research I'm doing translate to the knife companies? Yes. But some people put too much emphasis on the steel itself, or even the heat treatment. So a common thing will be, the heat treatment matters more than the steel. And that is kind of true. But also the design of the knife and the edge geometry matters way more than either the heat treatment or the steel. And ideally, you want all three to be optimized for the knife. Because you can have a heavy knife that doesn't cut very well, and it doesn't matter if it has the latest Uber steel with the super heat treatment lost from the ages that we've never figured out again, and it's still going to cut badly. And sometimes you see this on YouTube, people doing tests between different knives and then calling it a test between steels. And I don't like to criticize the YouTube testers. I think those tests are valid and fun and can teach us things. But sometimes what they think they're testing is not the same as what they are testing. So, you might see a video that's S30V versus XHP, but they're comparing like a buck knife to a Benchmade knife with completely different edge geometries. And you're just not comparing the steels. You're comparing the knives. And so you might learn something about the steels from that, but it could just be that one knife has a much thinner edge geometry and it's going to cut a lot better and a lot longer than the other, even if one has a steel that should last longer if it had identical edge geometry. So I think I'm losing track of what the original question was now, but
That's okay. I really like that answer, because it basically says that no matter who or what you're arguing, it's totally subjective, and that's usually where I find myself in things. So that's great, and I approve of the everything matters, and you can't just point one thing and choose your answer. It's just not how it works.
Yeah, it's very funny today. I actually got an email about edge geometry and edge retention no one really asked Knife Maker for information like that. It's like, oh, how do I sharpen your knives so they hold a better edge if I'd like to? I used to make kitchen knives like 4 years ago, and I had someone message me say, hey, I have your kitchen knife. I use it all the time, but I really don't want to keep sharpening it as the knife gets narrower. And he's like, what, can I sharpen it at a different angle? I was like, look, like I like to do 20 degrees. If you go any thicker, it'll hold the edge for a little longer, but it won't cut as well. If you go thinner, and vice versa. And then I introduced what a strop was to this guy. I was like, you don't really have to sharpen it, just get a strop. And he didn't even know about it. But just funny, he's talking about geometry being important, and today me getting an email about that, because usually no one really asks knife makers what's better for the edge, how to maintain it properly, how do I resharpen it. Usually I sharpen everything with a wicked edge to 20 degrees so people could resharpen my products easily instead of reprofiling them, which, yeah, I used to do it on the grinder back in the day, but that never really made sense to me, because if anyone actually tries to resharpen it, they're never going to match the angle that I did by hand.
Mm-hmm. Yeah, a lot of end users are afraid of changing that angle. So it does make sense to pick one that will be relatively easy for them to maintain, or to pick one that fits the knife. So if it's supposed to be a thin slicer, you might do a 15 degree per side sharpening or so. And a lot of people freehanding, they're taught like, put a marker on there, mark up the edge, and then see if you're removing the whole thing so you can maintain the angle. You have to think about the end consumer, and it can be frustrating to the knife maker when you put all this work into a knife, designing it to cut and to cut well and be easy to sharpen. And then they come back 3 years later and they're like, hey, could you sharpen my knife for me? And you're like, yeah, sure. And you look at the knife and it's obvious it has not been sharpened since it left your shop. You have to design knives for the consumer, and you don't always know who that consumer is going to be.
Mm-hmm. Yeah, that's why about 4 years ago I switched to a wicked edge and everything. I'll sharpen it on the grinder to 0, but I'll sharpen that like a freehand 25 degree, and then just jump on the wicked edge so that way I'm not spending the whole time there, and then adjust or reprofile it to a 20 and finish it up, instead of going through all the grits from a 12th thou edge down to a 0, essentially. It's a cutting edge with the wicked edge, which I used to do in the beginning, but I used to go through stone, like the diamond plates. As you know, they're not cheap like crazy, and so I was like, nah, I gotta sharpen these first on the grinder.
Yeah, one of my more controversial articles is about sharpening with a grinder. Oh, there was a lot of debate. A lot of knife makers were very upset with me.
Yeah, you'd I know you're probably talking about using the finer belts on the grinder, heats up the micro edge, stuff like that.
Yeah, so it was all about whether or not a grinder over tempers your edge. But there was a lot of talking past each other. There were a lot of knife makers that were defensive, because a lot of knife makers will put the final edge on with a grinder. So my article covered the small number of studies where they've looked at the hardness of edges after grinding sharpening on a grinder. There was an edge retention test that some undergrad students did, where they compared sharpening on a stone versus on a grinder. There was some statements from the Katra company. There was a test done by Global Knife Company where they compared stones versus grinders. So I put all that up. I wasn't that interested in writing about it really, but a few people asked me about it, and I looked into it, and I'm like, well, there's enough research here to report on it at least. But yeah, people were very upset that I said that sharpening on a grinder could lead to softening at the edge. One of the arguments, there were two major arguments against the article. One was that I've never had a complaint from a customer. Now, I don't know if you would have a complaint from a customer if you slightly softened the edge by over tempering it. Were they cutting, doing side-by-side cutting tests between your knife and other knives? I think without doing that, you may not notice a difference. Now, another thing is, if you sharpen the knife several times, then you'll get rid of that softened portion of the edge, and then it will no longer be an issue. It's relatively common in production knife buyers to say, oh, you got to sharpen a knife a few times before you really know how it's going to perform. The other major argument against the article or the research was that my knives come off really sharp off the grinder. Now, I never said that it wasn't going to be sharp. I said it was going to be over-tempered. So, if you over-temper the edge, it's a few points Rockwell softer than the bulk knife, so it'll cut a little bit less long. There's a chance you really overheat it, and then it would also be brittle. But you would probably know if you did that, though maybe not. But you can definitely get it softer while also making it very sharp. So I guess I didn't.
I know exactly what you mean. I've seen many knife makers sharpen their knives on a grinder, running the thing at 100% feed, so about 3,400 RPMs, which is fine. If you're really quick, you could still sharpen it out, messing up the edge. If you have a fresh belt, like I'll just see guys use I'll use a used belt because it's finer. I'm like, yeah, but that builds up heat. I thought about it back in the day. I spoke to Jeremiah a little bit about this before this episode. To what you're saying, knife makers get defensive. A lot of knife makers like to believe they make the best knives in the world. I like to always say straight up, you want a best knife, you want a great knife, don't buy my knife. I make a collector piece. Like, it's a good knife, but like, you buy a knife for $120 that'll be way better for everyday use. Ideally, I try to grind my knives carefully to not ruin the heat treat, but I'd admittedly say 9 out of 10 of my knives, heat treat's great. That 10th one, maybe the temper is a little not perfect because if I'm using ABL, the temper is 325 degrees. It's a pretty low temper. When I'm grinding it, that's even before you get a bronze color at about 420. So we all knife makers, we grind and we go, oh crap, it's bronze, temper's a little ruined. Steel's like ABL. Sometimes you could temper the steel out without even seeing any bronze marks, and you think all's good, but you probably dropped a point or two and you don't even know it. And I'll admit, like, yeah, that happens. But at the end of the day, I'm making a custom knife, and I'm doing the best I can. But admittedly, 1 out of 10 could be a few points lower just because you stay there too long, or it's just a low tempering steel.
Yeah, and it becomes challenging sometimes. They'll say, well, such and such master legendary knife maker sharpens his knives that way. Are you saying he doesn't know how to sharpen knives? And like, well, I don't know. Oh.
but I mean, essentially, I like that it's basically your perspective is taking the emotional characteristics of the argument out of it and just looking at the pure facts. I can appreciate that, which is just like, look, whatever the story is, it has to be based on like a scientific test. That's just it. Like, doesn't matter what it is. That I appreciate that. That being said, these tests, what interests you the most in the test? So you were saying before, you were kind of like, well, I'm not interested in writing about this or testing this. What interests you most about the test you do, or what do you want to test in the steels?
Well, I am a metallurgist, so in the end, this steel, the metallurgy, the heat treating is the part that interests me the most. But one thing I've had to do for Knife Steel Nerds is to learn a lot more about the overall knife itself. Now, it's not that I was not interested in that before, but, I was trained for a decade in metallurgy before starting Knife Steel Nerds, and so I knew metallurgy, and I knew lots of things that knife makers would say about knife construction or edge geometry. But I had to learn a lot more about that. Like I said, the edge geometry matters more than your steel choice. So if you're going to ignore those elements of the knife, then you're going to be really short-sighted. Somebody does a test comparing a high edge retention steel to a low edge retention steel, and the low edge retention steel does better. And you're just baffled as to why that would be because you don't know how the overall knife works. So I have expanded my horizons and been interested in more things. How does sharpness work? How does cutting ability work? What's the difference between sharpness and cutting ability? How does toughness testing of steel translate to chipping resistance in a knife edge? What controls a knife flexing or bending, or what makes one knife bend 90 degrees and another one snap? These are all questions that are somewhat related to the steel that's in it, but it's also an overall, the engineering of the overall knife. So I've expanded a lot more into that. You just can't ignore it. You have to learn about it to be able to talk about knives and knife steel. I'd say the different microstructures, the different characteristics of steel, how to optimize steel properties with heat treatment, those are my original passions. Those are my biggest interests. But I've had to expand my interests in what I learn during working on the website, and that it's really been a selfish endeavor. I wanted to learn more about knife steel, more about how knives work, and so I started doing research, reading papers and doing my own experiments, and so that's very rewarding.
Okay, no, I can appreciate that. You seem to be a person who's eager for more information on a specific topic, and that has to be totally respected. What about Damascus? Do you test Damascus?
I was about to get into that because I was trying to say that look at your website now. It's really well put together. You did a great job on it. But I haven't seen here, like, how much Damascus testing have you done? Because ironically enough, I'm actually working on 2 knives with some of your father's steel. And there's always the question of a lot of the stainless Damascuses are alloyed with 300 stainless steels. Have you done much testing with Damascuses that use 300 series stainlesses in it?
Only a little bit. So I have 2 primary articles about Damascus, maybe 3. One is called 5 Myths About Damascus Steel. That talks about both Woots and pattern welded Damascus. I have an article on the history of powder metals in Damascus, like using powder nickel or powder 1084 or 15N20 in Damascus.
Damascuses.
Yeah, so that was a fun article to do. I was able to interview a lot of Damascus makers about the history of pattern development and Damascus development. So that's kind of its own world unto itself. So one big test that we did, me and my dad, we went to Spyderco and we were able to use their Catra tester. So this was, I don't know when, maybe 2010 or 2012. So my dad made 3 knives, one in 154 cm, one in AEBL, and one was a 50-50 mix of 154 and AEBL. And
so it was a performance stainless. There was no 300 series in it. He just went with the straight, more synthetic, not more synthetic.
Right. So the goal was to see if there is a Damascus cutting effect, which is something which has been claimed, back to the 70s with Bill Moran, is that a softer steel or a material like nickel or a low carbon steel or a 302 would wear away more quickly than making sort of a serrated edge, which would cut longer. And 154 cm is much more wear resistant than AEBL, so we would expect the AEBL to wear faster. So we tested that. The 154 cm cut a lot longer than the AEBL, and the 50-50 mix between the 2 steels was basically right in between the 2. So we didn't see a Damascus cutting effect. It's basically just, a rule of mixtures, meaning, if you've got 75% 154 cm, then it'll cut better than a 50-50 mix between the 2 because the 154 cuts longer in a wear slicing test like that. So if you mix 302 into a stainless with Damascus, then it will lower the edge retention of the steel somewhat. Now, normally there's not that much 302 or 304 in a stainless steel, something like 10% or so, but it will change the properties of the steel. So Dama Steel likes to advertise that their steel doesn't contain any softer steel in it. So they use a mix of RWL 34 and PMC 27, which are sort of similar to AEBL and CPM 154. But most of the major Damascus producers that I'm aware of do have performance versions of steel. With my father's steel, people prefer the 302 alloyed steel. When he made performance versions, they didn't buy it because it was a little more expensive and didn't etch as well. So
there's a lot more. It's a lot more mute. Just the 304 it stays a nice shiny silver,
right?
But now it's gaining more popularity now as more guys are making their own steels. Like the stainless Damascus I make performance is the same mix your father made. Mm-hmm. curious, did you guys do individually test this? Well, in the Damascus layout under the same heat treat, were you guys able to test the hardness of both of the steels within the same homogeneous mix, I guess?
Yeah, it's not usually a good idea to, well, a hardness test of Damascus only tells you so much, especially when there's a softer material in the mix, because the hardness will read lower just because of the composite nature of the material. So if you have an AEBL 302 mix, for example, you want to heat treat for the AEBL. And then, through experience, you can see, okay, it's going to read about this on the Rockwell scale, even though that may or may not represent the hardness of the AEBL, if you know what I mean.
Yeah, but I'm referring to, so the performance that I make is the same ABL 154 mix.
Uh-huh.
They have very similar heat treats, so I'm assuming it's probably within a point or so.
Yeah.
But I was curious if you guys did testing on the hardness of both of the steels within the same heat treat.
In the case of our Catra edge retention test, or just generally?
And generally, in the case of like your dad's billet that contained just 154 cm and ABL, did you guys try to Rockwell test individual steels within the billet to see if they Rockwell similar?
Oh, yeah. So, I mean, there's a reason why those mixes are used, because the steels do heat treat relatively similarly, like you said, and they have a contrast difference when you etch them with hydrochloric or a couple other etchants.
Periodic.
Yeah. Well, muriatic is hydrochloric acid.
I never knew that.
No, the high moly in the 154 cm causes it to be brighter. Oh, it doesn't etch as dark as the ABL in a hydrochloric acid. So that's why they are used. In the case of the Catra experiment, we of course measured the Rockwell on all three knives, the 154, the ABL, and the mixture. I don't remember what those hardness values were. They were very close, like one was 60 and one was 61 or something. So
yeah, okay. I assumed they would be in about within a point or so within the steel.
Yeah, 154 does heat treat a little bit harder usually.
Yeah, because I got some knives in the bench right now. One in the performance that I made for a personal carry, and then I actually have some steel from your father that I bought about 7 or so years ago that has been lying around.
Yeah, I think making stainless Damascus has been growing a little bit. More and more people are learning how to do it. For a long time, it was my dad and Mike Norris and Damasteel, and that seemed to be about it. Either there wasn't interest or they couldn't figure out how to make it. I mean, historically, a lot of Damascus makers use carbon steels because they're forging bladesmiths using carbon steels. So there wasn't that much drive to make stainless, and they didn't know how to make it. But I think the knowledge is slowly growing.
Definitely, there's definitely guys out there. I'm not even a forger, and I've done forging as a hobby. It makes me no money, but I do forge with Damascus because I like it, and it's just awesome to say. I haven't made really any builds in it, but I do have a few builds that I've made in both titanium Damascuses and performance stainless Damascuses. Just nice to say as a Fuller maker, will be a sole authorship piece to where I made everything in here down to the steel, but the bearings essentially is what guys say.
Yeah. Yeah, so I like Damascus. That was one of my early interests. When I first got on the different forums, I'd usually just go and do a search for Damascus and see what people were talking about before I expanded into other things. So, the history of Damascus and pattern development, how different patterns are made, how stainless Damascus is made versus carbon steel Damascus. Those are all interesting subjects to me. So that's part of what was fun about doing that history article on powder Damascus, is I was able to call a lot of guys that were very influential in Damascus in the 80s, 90s, and early 2000s. So that was a lot of fun connecting with more of those guys.
Do you keep contact with any of them now, or do you work closely still with your dad at all, or is there any connection there?
Well, there is a strong connection with my father. I call him, most days, probably. We don't always talk about steel, but we do talk about steel a lot. He also asks me how my kids are doing and how my job's doing. And, I tell him about how I went to the grocery store and other exciting topics like that. But me and my dad talk a lot, and I tell him what's going on with Knife Steel Nerds and different experiments that I'm doing. And so, yeah, me and my dad are tight, and I got to know a lot of knife makers over the years, and a lot of people know my father. So, calling up all of those knife makers and Damascus makers about what happened in back in the day was not that difficult. So, I just cold called most of them and said, hi, I'm Laren. And they either said, oh, I remember you, or they said, who are you? And I told them who my dad is and what I was working on. And so it wasn't that difficult. I've had good luck in the past just calling knife makers, some of some fame and some lesser known, but working with knife makers has always been rewarding. Going to knife shows was always fun to get to know the different knife makers. They come in all different personality types. There's like cowboy type guys that, they wear the hat and the boots, and they, talk about how this knife will be good for a cowboy or whatever. And then there's, more serious self-defense guys. They usually work out and got the muscles to go with the knives that they sell. And forging bladesmiths, they have their own style. Some of those are also the cowboy guys, and so you get to know knife makers, and and I've had really good experiences with knife makers in general, not too many negative ones. One experience I always remember is we were going to the Eugene, Oregon show, and we went there with Bill Ruppel, who is a Texas slip joint maker. He's very well known, very famous, known for teaching a lot of guys slip joints. I had no idea who he was, but I went on a trip with him up to Eugene, Oregon. So I guess Bill doesn't like to fly because he was driving all the way from Texas. So he came in his fancy new truck and picked us up in the middle of nowhere in Nevada, where I grew up. And we all got in the truck the next morning, and we started driving out of town. And we got like a mile out of town, and I was getting really car sick. So I haven't hardly even been car sick before. That was like the first and only time. And so I'm in this fancy Ford F-250 or whatever it was, and I'm feeling real bad. And I'm like, Bill, you got to pull over right now. So he pulls over, and I get out, and I'm just like puking all over the ground. And, we're like a mile out of town. And Bill's got to be thinking, like, what have I done? So I think I took some Dramamine, and we continued the trip. But Bill's a really cool guy. To me, he was just the guy we were traveling with to the Eugene show. I didn't realize he was a legendary knife maker, really. We listened to a lot of country music since he's from Texas. We talked about the peanut farms. I bought some jazz CDs, and those drove him crazy on the trip. And he gave me a slip joint folder that he made at the end of the trip. And of course, his knives were worth a lot then and even more now. And a lot of the knives that I own were given to me by knife makers because, there's a lot of very giving, kind knife makers. And so, yeah, the trip with Bill Ruppel is just one example of the good experiences I've had with knife makers and knife companies. Sal Glesser, I've always had really good experiences with. Of course, the owner of Spyderco and his son Eric, they've given me knives. They let us do those Catra tests on the Damascus steel. I visited them a couple times. I should mention Colorado School of Mines is in Golden, Colorado, where they make Spyderco knives and Coors. So I was able to go to Spyderco a handful of times while I was there. And so, yeah, in general, I've had really good experiences with knife makers. So I can tell you some negative stories too if you want, but there's not nearly as many of those.
No,
those aren't as flattering.
Mm-hmm.
Before I take a deep dive into your website, so have you done any testing on Chinese steels and their hardnesses and their honesty behind it?
Not really. I don't do that many tests of final production knives unless there's something specific I want to look at. I don't really review knives or give recommendations for specific knives to purchase. And I really like to control my variables. So testing a finished knife takes away all of those choices from me. I don't control how they heat treat things or what the edge geometry is or anything. I know there are some people that have been trying to test the composition of different knives, particularly imported ones, to see if the steel is what they claim it is. They've mostly been using
the radiology test.
Yeah, they've been mostly using technology called XRF. I forget what that stands for, X-ray fluorescence, I think. So there's these little PMI guns, like metal identification,
there's a local scrapyard when I have because I have like I mentioned, I was an NJ Steel Bearer for a while, so I have a lot of like random steels. So once in a while I find this pile of steel. I'm like, this seems like the right thing I need, but I don't know what it is to heat treat it. So I go to a lot of scrapyards usually have those guns.
Yeah.
I bring it over, they'll test them, I'll look at the charts and figure it out. I actually just did that because I was trying to make a steel stamp today, and I had a bar, and I was like, I don't know what this is, but I think it's W1. And I took it over, and I'm like, oh, yeah, it looks like W1. So kind of worked out. He treated it.
You should be a little bit careful with that because the XRF guns, they don't have perfect accuracy. Any test has some variation within it, and XRF guns are not the very best method for measuring composition, particularly when they're checking to see if something's actually D2, because the XRF guns do not measure carbon content. And so, if it had 1.5 carbon in it, then it would be D2, no question, most likely. But, sometimes they're testing something and it's 13 or 14 chromium when they're expecting 11.5 or 12. And I'm not sure if that's enough evidence to say it's definitely not D2. I'd probably want a more reliable composition measurement before I was really sure that they were advertising it as D2, but it wasn't. Those kind of tests can be fun. It can be exciting to do the gotcha game. You think you're getting this good knife, but it's not, and it's false advertising. But I would wait for more reliable measurements before I was ready to throw away a knife.
No, I know. I mean, for me, I've used about the same 5 steels over the last 10 years, so it gives me an idea which 5 I'm dealing with at that moment from the scrap pile.
Yeah, for your uses, it's perfect.
Yeah, it's not like, which out of 100 steels, what is this? It's one of these 5, and I can figure it out if they test it, because it's literally 2 minutes away from me.
Yeah, I wish I had one. Oh, they're expensive. They look small, like they'd be cheap, but no, they are not cheap.
No, it's a piece of high tech equipment.
Yeah.
But I went down there. Someone told me, I was like, every scrapyard should have one. So I just drove down there. I was like, hey, do you have this thing? Can you test this? He's like, oh, sure, no problem.
Yeah.
And then I tried to bring him titanium. And the guy's like, oh, that's crazy exotic. I'm like, oh, really? I have like buckets full of this stuff.
Yeah.
This is all just titanium, my guy. So you so you have a Patreon, you have a website, you have Instagram, you have all these sources of material that you regularly write on, it sounds like. I mean, how often do you publish new articles on your website?
Yeah, for a long time I was doing every week. I did that for a couple years. I decided that wasn't sustainable. I wasn't really burnt out, but I was worried if I kept going at that rate that I would be burnt out. And I was running into times occasionally when, like, I don't know what I'm going to write about this week. So I just got to find something and write about it. And so to make sure that my quality wouldn't slip and I wouldn't burn out, I switched to, I'm basically doing every other week, sometimes twice a month. So there's definitely regular articles coming out. I was driving myself crazy having a very strict schedule, which I think wasn't that great of an idea. And people don't need 3,000 more words about knife steel every single week. So every other week is working pretty well.
Now, after all your testing, and what would you say is your favorite? What would you say is the best all around steel, and what would you say is your favorite all around steel?
Yeah, that's a really hard question because, of course, we know that everything is a trade-off. There's no perfect steel. And
well, in my question, where I'm talking for everyday carry, what are you like? Not it's the toughest, strongest, whatever. 125, yeah, that's cool and all, but like you're not gonna want to sharpen that all the time and carry it every day. But what's like, for example, my favorite for all around use is CTS XHP when it's available.
Mm-hmm. Yeah, XHP is not my favorite. it's not bad. But I've done a simple corrosion test on a bunch of steels. I heat treat them and finish them to 400 grit to represent kind of a rough production finish, and then I spray them with distilled water to check if they're stainless. And I've only had 2 stainless steels fail that test, and one of them was XHP. The other was ZDP 189. And then after they pass that test, then I move on to a 1% saltwater test. And for most of the knife steels, I've been able to differentiate between the different ones using 1% saltwater. But I'm getting sidetracked on corrosion resistance. So one of my favorite steels is AEBL. So my dad used it in Damascus for a long time. John Verhoeven wrote about it in his book. And I have a big article on it, of course. So the history of it and the design of it is very interesting to me because it's a stainless steel that's designed for high toughness and fine microstructure, which are properties that are usually thought of as being simple carbon steels. So they were able to design a stainless, way back in the day in like the 50s, 60s, that had a structure that was just as fine as a carbon steel for razors, but was still stainless and had high toughness. And so that steel can take really thin edges. I like thin edges with low angle grinds on them so that they cut really, really well. And AEBL does really good at that because of its high toughness and fine microstructure. Of course, it's very easy to sharpen. So I really like AEBL. Now for tool steels, my favorites are probably CPM 4V or Venatus 4 Extra or CPM Crewware. Those are kind of in a similar category. And those are all powder metallurgy steels, and they have kind of medium edge retention, a little bit higher edge retention than AEBL, and a little bit drop in toughness, but they have a really good balance of edge retention and toughness. And what I would really love to do with steel design is to make something in that property range, but is also stainless. And it's really challenging to do, because you're trying to balance corrosion resistance against those other properties. But I have a really good idea of how to do that, and we'll see if we can make it work.
Yeah, I'm not too familiar. I haven't really used Crewware. ABL I'm very familiar with. I've made thousands of knives in it. About 80% of the knives that I've left in my shop are out of ABL. So I do like ABL, but overall, because I also factor in actually working with it. And ABL is actually very easy to work with, even easier than CTS XHP. I just, for some reason, that CTS XHP, it finishes more evenly sometimes. ABL is very consistent, but sometimes CTS, I don't know if it's the consistency of Carpenter's roll. I just always liked it overall working and using it. But yeah, ABL is a pretty close second for me. Also, I just like the ABL because it's relatively easy for me to get because I just have to drive about 25 minutes and pick up as much as I need.
Yeah.
That's a nice factor.
ABL is cheap and it's easy to work with. The main complaint about it is usually warping. Because they make it in coils, and the steel really likes to go back to that shape that it was in before you turned it into a flat knife. So that seems to be the main complaint about the steel from knife makers.
Yeah, in the last few years, I started normalizing all of it because I do mainly folders, so I normalize all my titanium. So I started normalizing most of my steel as well. Reduces a lot of that. But I know definitely a common complaint I hear. Once heat treating, it tends to go back, especially after tempering.
So as a project, the Knife Steel Nerds, maybe project isn't the right word, but maybe it is. Where is this taking you? Where's the destination of this? Where are you going to be in 5 years with this? Still doing this or developing? You're talking about developing your own steel. Can we get into that a little bit? What's your eventuality?
Yeah, I don't think there's really a master plan or a goal for Knife Steel Nerds. Some people have criticized me for not having a master plan. I need to be trending in a certain direction. But basically, it's a hobby project of mine, Knife Steel Nerds, and whatever that ends up being is what it is. So I try to keep whatever's in front of me in mind and not get lost in what I might do later. Whatever experiment or project I'm working on, I kind of focus on that. But I mentioned doing some consulting projects and designing new steels, working with different companies to try to make those happen. None of those are ready to announce, obviously, like I said. So it's all connected, but it's all kind of separate. Knife Steel Nerds was not a website to promote me in any way. I didn't start it to, because it's all leading up to the release of a book or the release of a steel or something. It's all just my hobby, Knife Steel Nerds. So yeah, I'm just doing one thing at a time. But if you want to talk about steel design specifically, we can try to get into that if you had any questions to get started.
I mean, I have no concept of how to even start to start that. So I mean, yeah. So you're trying to design. I mean, I don't know. I would imagine that's trying to design something that's very hard given the amount of product already out there. But I mean, I suppose that's what intrigues you, is the challenge to create something new and better than the rest.
Yeah, there's a long history of steel development, and I'll try not to get too much into the history, but one of the fun things in Knife Steel Nerds has been trying to find the history. It's very difficult. Most of it is not easily Googleable. If you just type in history of D2 tool steel, you'll find a lot of one paragraphers that are mostly incorrect. So trying to find the history of different steels is fun. How did they develop them? How did they figure out how to get certain sets of properties? So that's been fun for the website. But when you're designing a steel, you're really looking at the different trade-offs that are available and trying to see what the gaps are in the market. What are customers interested in? What are knife companies interested in? What are knife makers interested in? That if it were available, they would want to use it. Now, there's a whole host of things that go into that. Maybe your big three properties are toughness, edge retention, and corrosion resistance, assuming you're making a stainless steel. But then there's a whole bunch of things that go along with that. Nick mentioned the ease and finishing of XHP. Knife makers care a lot about finishing. Knife companies don't care as much about ease and finishing. They more care about grindability, removing material rather than the final polishing of it. And then there's ease and heat treating. Certain steels you have to austenitize at high temperatures. 15 years ago, 20 years ago, a lot of guys had Paragon brand furnaces that topped out at 2,000 degrees. So if you came out with a knife steel that had to be heat treated at 2,100 degrees, they couldn't use it. So those are some of the things you have to be aware of when you're designing a steel. But then there's also breakthroughs in design or development. Over the decades, they discovered new things. One big one was powder metallurgy that was introduced in the very early 70s by Crucible. And powder metallurgy led to finer microstructures. They were able to make steels that had better toughness for a given level of wear resistance just due to the technology that they were using. And when you're designing a steel, you have all these different variables you're trying to optimize. Like I said, heat treating and polishability, grindability are some of them, and you do that by controlling the microstructure of the steel. So you're designing it with a certain composition to try to get a certain set of carbides in your steel. The carbides are those hard particles that give you wear resistance. So you want to get the right carbide structure to give you your combination of toughness and edge retention that you're looking for. And at the same time, you got to have the right amount of carbon in the steel so that it hardens to the right level. You got to have the right amount of chromium so that it's going to be stainless. And all of these things compete with each other. So you add more and more chromium, and the structure gets more and more coarse, and eventually you have poor toughness steels. And that's part of why for a long time people bragged about their carbon steels being way tougher than the stainless steel knives that were available, just because the microstructures were so much different between the two. So when I'm designing a new steel, I really want to hit a region of properties for something that is not in the market that people would be interested in. And I want to do that through some innovation in the microstructure of the steel. I want to eliminate or add something that hasn't been done because it's very challenging. So when I want to design a stainless steel that's just as good as a non-stainless steel, one of the things I want to do is try to get rid of the chromium carbides. Now, I'm going to try to explain this as simply as possible without getting too technical for the podcast. But carbides come in different hardnesses, all the way from iron carbides and simple carbon steels up to vanadium carbides in a lot of the so-called super steels with really high edge retention. And vanadium carbides are very high in hardness, so they contribute more to edge retention. The harder the carbide, the better the wear resistance and the better the slicing edge retention. Now, carbides are also bad for toughness. The more carbide you have, the worse the toughness is. So you want more carbide in there to make it have better edge retention, but more carbide also makes the toughness worse. But harder carbides aren't any worse for toughness. So a vanadium carbide doesn't necessarily drop toughness any more than an iron carbide, even though it's much harder. So if you have the same amount of carbide, but it's all hard vanadium carbides, then you have better toughness for a given level of wear resistance. So you have a steel with 8% iron carbide or chromium carbide versus 8% vanadium carbide. The toughness is sort of similar, but the vanadium carbide version is going to cut a lot longer. So if you can get rid of those softer carbides and have only vanadium carbide, then you can optimize your toughness edge retention balance. And with stainless steels, all of the available ones all have a very healthy amount of chromium carbide. And one other side note is that in powder metallurgy steels, the chromium carbides are a little bit bigger than the vanadium carbides, which also makes them worse for toughness. So stainless powder metallurgy steels actually are worse for toughness than their non-stainless counterparts because they have chromium carbides in them. And if a smart metallurgist was able to develop a stainless steel without chromium carbides, then you could match the properties of the non-stainless steels. You could match a CPM 4V or a Venatus 4 Extra or a 10V or a 3V, but with stainless levels of corrosion resistance. So that is the goal. And I don't know why no one has done it. It appears to be possible according to modeling software that is available. So I think maybe they've tried it and it didn't work, or maybe they have certain design historically that they've used that they have a hard time letting go of. But I think it can be done, and we'll see. We'll see.
They just weren't you. That's the problem.
Yeah, it's because I'm so much smarter than all of these PhD metallurgists that came before me or are currently working.
Well, I mean, like I've seen a lot of tests in the past. People make a steel on paper; it seems great, but then it's held a heat treat, or they'll heat treat it and it'll work as a steel, but it finishes for example, like the first batch of Nitro V I used. The first batch they did, something was off in the numbers, or the original formula wasn't great, and steel looked great. It worked fine. It ground fine. The heat treated properly. Got the 61 that I wanted. But I'd grind the satin grind, and there'd almost be what looked like a hamon within the satin grind. It wouldn't show up in the edge. It almost looks like a fracture within the steel, like a crack, and things like that pop up when they were making new steels. Because every time an NJ Steel brand made something new, or they received something new, or for something for testing, I usually tried it, and I always made sure I heat treated it in house and finished it in two ways: one acid ferric chloride etching it to see how it came out, and then one doing a satin grind and just shimmering the actual, usually a 220 grit, because you would see a nice grain structure with a 220 grit. To see what it would look like. And the first batch of Nitro V, I had that issue where most of the time a satin grind would have this almost, like I said, look like a crack going down the edge, not the edge, halfway down the hollow grind, catching light in a weird way. Almost, like I said, almost looks like a hamon. Main reason I always use 220, like I said, I usually use 5 steels And when they're raw, I can't really tell what it is. I could almost, by the scale, I could see if it's CPM or who rolled it. Usually based on the surface finish, I could tell. Uh, but if it's hard and I grind it with 220, I could call out 4 out of those 5 steels I use just based on how the sheen of the grind looks like, just out of experience. And that's a test that happens with like new steels, like you mentioned. On paper, it might seem like it works great, but once you heat treat it, it might not look great, or it might not grind great, or it might not etch great. And for knives, at least, it kind of all those factors really matter. As you mentioned earlier, like knife makers, we look at it as one way. We don't just look at it as an end result. We also see how it is to work with them.
Yeah, there's two big things you're bringing up there. One is that you can design a product and you can hit all of your design goals and it performs just how you wanted it. But it's just not what the customers want for whatever reason. You know, you made a sports car for grandmas and they wanted a comfy SUV. You know, you didn't make the right product for what the people want. Or you made 15V and you wanted to make the most wear resistant, highest edge retention steel ever, and the knife makers didn't want to use it because it was too hard to work with and it wasn't stainless, you know, something like that. The other thing is you can develop a product in the laboratory or with computer modeling, and it looks great. You know, first you make it in a model or kind of with some qualitative, thinking like, oh, I need to add a little more carbon or a little more of this. And then you make it in the lab and it looks great. Then you try to make it at a production manufacturing level and it just fails. You know, something isn't working, or, you know, it's not when you're making it at a mass scale, it's not forming the same kind of structures as it was in a small scale in a laboratory production type environment. So, you know, you can develop something and it can look good at a lot of different stages and then end up failing for different reasons, either in the manufacturing of it, or the end customer can't work with it, or the end customer just didn't want that product. So when I'm talking about steel design, there are no guarantees. So I could work on something that looks awesome to me and it doesn't go anywhere. But that's product development.
Mm-hmm. There's one more thing that I had on my list that I forgot to mention earlier. Have you messed around much with spray form steels? I've been interested in trying that PSF 27, the spray form, because right now I'm working on a fixed blade project, and essentially it's going to be made in batches of 60, but every 60 is going to be a different steel. So I've been looking into the PSF stuff since I don't really have much experience with it, and it just interests me since I haven't really used it. One of the biggest factors for me for steel, like I said, once for finishing, the first thing I do with a steel is once I make it, I do an acid wash. If the acid wash doesn't look good because it doesn't take a good acid edge, can't use it, because custom knives are more about aesthetics than function in reality.
Sure, I won't argue with you about aesthetics versus function for now. We'll leave that aside and we'll talk about spray form steel. So spray form is an intermediate technology, intermediate between conventional steelmaking and powder metallurgy. So with conventional steel, you know, they melt up a big vat of liquid iron. They add some carbon and other elements to it. They pour it in a mold, and it slowly solidifies into a big steel ingot. And that leads to somewhat coarse structures because it slowly solidifies. Alloying elements will segregate to each other. You get carbides that grow really big, where with powder metallurgy, they take that liquid steel, it goes through a small nozzle, and it gets sprayed with nitrogen gas usually. And as it sprays that liquid stream of steel, it rapidly solidifies these tiny particles. You know, it's like a powder. And then they take that powder and they put it in a big can, and under temperature and pressure, it creates a solid ingot that they then work like normal. So because the steel solidifies so rapidly, the final microstructure ends up much finer. So spray form, rather than the steel completely solidifying into powder and then they put it in the can and hip it, what they do is that the table at the bottom, where they're spraying the powder onto, they move it up so that the steel is still partially liquid. It's still solidifying. And so they have this rotating table where they're spraying this semi-molten powder onto it, and they build up an ingot that way. So they kind of skip that step where they have to put it under high temperature and pressure. So it comes out as an ingot at the end. But it's intermediate between the two technologies because it doesn't solidify quite as rapidly because of the way they do that, where it's semi-molten.
So it's not as fine as powder metallurgy.
Yeah, so on my website, I have comparisons between D2, PSF27, and CPM D2. Those are all identical composition, but made either conventionally with spray form or powder metallurgy. And the PSF, yeah, so the PSF27 is right in between the two. It might look a little closer to powder metallurgy than it does to conventional. There's not a lot of spray form steels available. PSF27 is really the primary one that you can buy with any regularity right now, at least for knives.
The only one I'm really familiar with. As you mentioned, I haven't really seen any others. Now, I got to read your article on that because, like I said, I just wanted to try it because it was something different because that project was specifically to try different steels out and see how they finish. And for guys who are collectors, who actually the fixed blades are more for using, if they wanted to buy the same knife in multiple steels just to mess around with themselves, that would be a project that I wouldn't heat treat in-house. I'd outsource for better results. But I got to read your article, like I said, because I was under the impression, based on what I read, that spray form was actually finer than powder. That's what I read.
It's in between. Now, I did heat treat a CPM D2 toughness specimen a long time ago, and I'm still waiting on it to be machined. But we have tested PSF27, and it did have considerably better toughness than conventional D2. So the finer microstructure did improve the properties. So I'm interested to see how much better the CPM version might be.
Interesting. Okay. We'll definitely give that article a read.
Yeah, so search for 42 micrographs. It's actually much more than 42 micrographs, but that was the original. So micrographs just meaning a picture you take with a microscope of the steel structure. And I've got pictures of a lot of different knife steels.
A lot, yeah. So notice you have a lot of photos on your site, like under microscope. Are you just pulling those off online, or are you taking those yourself?
Yeah. So at the beginning, I had to use what was available, in the literature, or I got some micrographs that were taken by Sandvik Steel a long time ago. But anything in the past year or maybe 2 years were micrographs that I took. So what I do is I heat treat little steel coupons in my garage, in my furnace. And then equipment for making metallographic specimens is very expensive because they all sell it to big laboratories and universities that have, mostly just buy things without question. So I couldn't pay for most of those things. So I bought just some regular epoxy and to make these little cylindrical like mounts that are common for microscopes, metallurgical microscopes. I bought a pink silicone muffin pan off of Amazon. So I just stick the steel specimens in the silicone muffin pan and I mix up the epoxy and pour it in and let it harden. And then I bought a lapping machine, normally used for polishing rocks. That was a few $100s off Amazon. I bought some sandpaper to go on it, and then I polished the steel on there, and I ordered some acid. Well, first I ordered the acid, then they rejected me because I'm not a real company. They can't ship to a residence, apparently. So instead I shipped it to work and hope nobody asked too many questions. And then, so I got the acid. You have to etch the steel in acid so that it reveals the different microstructures. And then we have microscopes at the company where I work, and they just sit there most of the time when nobody's using them. So I can go in and look at the steel, and I take pictures. They're very nice little microscopes. It'd be expensive to get one just as nice for my house, maybe someday.
Yeah, that's why I was asking, because the photos you're taking, they look just like, pretty much like the professional ones out there on spec sheets.
Mm-hmm. Well, I am a professional.
Spec sheets or because as you mentioned, like it's really expensive equipment, but you're kind of DIY garage rigging it there with the epoxy setup.
Yeah, it's kind of a strange mixture between me doing work in the garage as a hobby, but then I don't want to do it if I can't do it right. So what I can do in the garage, I do in the garage, and what needs nice equipment, I find the way to get it done.
Yeah, I mean, sometimes that's whatever it takes, any means necessary. I like the idea of you bringing in like steel subjects to take photographs at work. I mean, I guess it's all steel, so probably nobody really asks any questions.
Yeah, sometimes people ask, I'll tell them about knife steel, or whenever they hear about my dad or knife steel, they ask me about forged in fire, because that's the only thing they know about related to knives.
I get that every 3 days.
Yeah, so here and there, I worry that some manager might get suspicious, and they think that the equipment should only be used for this or that, even if it's not doing anybody any harm or costing anyone any money. But in general, people have been interested, and they'll ask some questions. I'll talk to them about it, and so I haven't had any issues. I think in general, people have been supportive. As long as I'm getting my work done. So, boss, I know you're still listening. I'm getting all my work done. Don't worry.
That's awesome. That's very cool. All right. Is there anything that we didn't cover that you wanted to share?
Well, probably, but I'm doing steel research, and if you're interested in steel, come on knifesteelnerds.com or follow me on Instagram. And I'm talking steel, so if you wanna debate about whether 204P is better than 20CV, then you can come talk to me.
There we go. I'm sure that there are, and I know that there are lots of people who would love to do that.
Yeah, there's a surprising.
And you have a Patreon as well, right?
Yeah, the Patreon. When I first set up the website, I wasn't planning on getting any money for anything. Just this was going to be my hobby where I wrote about stuff, but then I wanted to do experiments, and I just couldn't afford to do them. My wife is not happy when I buy, $2,000 heat treating furnaces just to feed my website with content. So I set up the Patreon. I hoped I might get, a handful of people, and it turns out way more people want knife steel research than you would guess. I forget how many supporters I have now. I think it's over 150, which is it. If you had told me that 3 years ago that 150 people would want to pay money to get knife steel research done, I would say there's not that many people interested. But so, yeah, and all of that money is being spent on equipment and steel and other costs of doing stuff, shipping things, and just everything adds up. The Catra edge retention experiments we talked about, between the cost of my consulting and the cost of material and the cost of getting them all ground and produced and the paper stock to cut, that's been about 12 grand, and about a third of that was covered by Patreon. So without Patreon, there's no way my wife would approve of all of these experiments. So if you want the experiments to keep happening, then yeah, come on Patreon. It's been amazing for what we've been able to get done.
I mean, that's awesome. That's a huge amount of support. That's legit.
Yeah.
That's great.
I have people that contact me and are excited to talk about steel, or knife makers with questions, and I don't even charge my standard consulting fee for all of their questions about their bad heat treating. So, come talk to me on Instagram. I won't charge you any money. I probably should. So an earlier version of my Patreon said, if you were a supporter, you could ask me questions, but then people send me emails and I just answer all their questions. So I had to remove that from the site. So it comes up pretty frequently. I heat treated this and it warped bad, or I heat treated this, it came out at 50 Rockwell, it was supposed to be 62, or, it happens all the time. So I'm happy to answer questions.
All right. And you did mention shows. Do you still go to knife shows?
I haven't been to a knife show in a couple years. I was planning on going to Blade Show, but of course that's been delayed. So I don't know right now if I will go. I had to cancel my hotel reservation that I had. So I was excited to go to Blade Show again. But so I hope to go to more shows. I'd love to get invited to more hammer-ins or other events like that, assuming they ever start again, or if we're just living in the apocalypse now. So yeah, presenting at hammer-ins or talking to people at shows, that would be great. I'd like to do more of it. So I've only gone to, I don't know, a handful of small events over the past couple years since Knife Steel Nerds started.
Well, I think it would be great to have you out at some shows. I'm sure that you would probably just be completely overwhelmed by an intense amount of questions, only half of which would be asinine.
Yeah, all my adoring fans.
It would be great to have a table.
I'd have to push them away, hire a bouncer.
There you go. Yeah, bodyguard. Yep, exactly. All right. Well, yeah. I mean, I think we've covered it, and on that note, I think we're gonna wrap it up. I really I appreciate you coming on and taking time with us on the podcast today.
Yeah, anytime.
Note, Nick Trupin here. You could find me at NCC Knives on Instagram, nccknives.com, and get in contact with me on my contact page on nccknives.com.
This is Jeremiah Burbank with PVK Vegas. You can find me on Instagram on my day job at PVK Vegas or my personal Instagram, PVKJer. Thanks for listening.
Yeah, check me out at knifesteelnerds.com. On Instagram, I'm knifesteelnerds. So we've got lots of fun content. So please come and talk to me about steel. Thanks, guys.